Lesson 21, Prime and Composite Numbers and Prime Factorization. The definition of prime numbers is it's a counting number with exactly two factors. And the two factors will be the number itself and 1. So 1 cannot be prime because it only has one factor. So we start with the number 2, and 2 has factors 2 and 1. So it is prime because there's no other factors of 2. So another example would be 3. It's 3 times 1, there's no other factors. And 5. Okay, so these ones are prime. I do have a poster in the back of the room of prime and composite numbers. You'll notice that 1 is not on the list. All the numbers in white are prime and all the numbers in blue are composite. So I don't know if you can see that right next to the gallon man. So 1 is not on the list because it's neither prime nor composite. Okay, the definition for a composite number is a counting number that has more than 2 factors. So for example, 25 has the factors 1 and 25 and 5 and 5. So those 3, 1, 5, and 25. 12 has the factors 1 and 12, 2 and 6, and 3 and 4. So these are composite numbers because they have more than 2 factors. So factor pairs are the two numbers that go together. So when we're writing out our factors, the 1 and the 12 would be considered a factor pair. The 2 and the 6. So they are, the way I can explain this, I guess, is through an example. So, example. We're going to do for 21. So 1 and 21 is a pair, and 3 and 7. So these are the factor pairs for 21. The factor pairs for 24 are, so we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. I think that's all of them. So there's 4 pairs of factors for the number 24. Now, prime factorization, it basically means you want to take a composite number and figure out which prime numbers are needed to multiply to that particular number. So we teach 2 ways to find the prime factorization. One is called the factor tree. And we're going to do an example with the number 80. And you just pick 2 numbers that multiply to 80. And it doesn't matter how you start, because I think there's several. We can do 8 and 10, 40 and 2, 20 and 4. I'm just going to start with 8 and 10. There's no right way to start. You just need 2 numbers that when you multiply give you 80. If they're not prime, then you think of two more numbers. Neither of those are prime, so we need to think of two numbers that multiply to get 8. Any two numbers, yeah, what do you got?
8, 2 times 4.
2 times 4, so we could put 2 and 4. And right away I can see 2 is prime, so we're going to circle it. And 10 we can do 2 times 5. And both of those are prime, so you circle them. And then 4 is not prime. Sky? 2 times 2. You got it. So then we circle it. And when we write the prime factorization, we have to write it out as 80 equals, and then you're going to list 4 2's, so 2 times 2 times 2 times 2, and then times 5. And you have to have the multiplication dots in between. Now, because we learned about exponents yesterday, we're going to write using exponents. So instead of writing 2 times 2 times 2 times 2, we're just going to put 2 to the 4th. Then we have a division by primes. It's like a cake tower. So you have to start near the bottom, and we're going to divide 225 by a prime number. 5 goes into it, so we'll divide by 5, and 5 goes into 22 4 times with 2 left over, and 5 goes into 25 5 times. Then you take 45 and you need to divide it by a prime number, which is 5. You can do 5 again. That will be 9. 9's not prime yet, so we need a prime number that goes into 9. Alexis? 3. And then you have 3. So when you end with the prime number, those will be the prime numbers that will make up 225. So we could say 225 equals 3 times 3 times 5 times 5, and then we want to use exponents. So 3 squared times 5 squared. Okay, and there's one more topic for our lesson, and it's the greatest common factor. So I'm going to give you the steps of how to find the greatest common factor, and then we'll do some examples and follow those steps. So, greatest common factor, we will usually use GCF to stand for greatest common factor. So to find it, step 1 is list out all the prime numbers for each number given. Number 2 is circle the shared factors. And then 3 is multiply the shared factors. Oops, that's a ditto mark. So we are going to show you an example. Okay, so find the GCF, or the greatest common factor, of 18 and 81. So I'm going to do the factor tree for 18, and we'll do division by primes for 81. So 18 is 3 times 6. 3 is prime, so I'll circle it. 6 can be written as 2 times 3. So right now we have 18 equals 2 times 3 times 3. And I actually write it out without exponents. Then 81, I'm not sure if I have enough room to do this. Let's see. Sky?
9.
But that's not prime. We have to divide by a prime number. So 3 would go into 81 27 times. 3 goes into 27 9 times. And 3 goes into 9 3 times. So 81 is 3 times 3 times 3 times 3. They both share 2 3s. So we circle what they share. Circle the shared factors. 2 3s. Then you multiply those shared factors. So the greatest common factor is 3 times 3, or 9. So 9 will go into both 18 and 81, and that's the largest factor that will go into both of them. We're going to do one more example. And this is with 3 numbers. So 20, 40, and 60. So we're going to list out all the factors, the prime factors of 20. So we can do the tree. That's 4 times 5. And 4 is 2 times 2. We circle the factors. So right now we have 20. 2 times 2 times 5. Wait, 40 will just be one more 2, right? Because it's 2 times 20. So I can just put 3 2s and a 5. And 60 is 3 times 20. So I can take my 20 and add a 3. Whoa, I didn't even have to do factor trees on all those. That's awesome. So the common factors, 2 2s and a 5. So we're going to do 2 times 2 times 5. So the greatest common factor is 20. 20 can go into itself once, into 40 twice, and into 60 3 times. Gabby.
After you did the factor tree, you really didn't have to write out the prime numbers because, like, you said that, look, 20 can go into these,
I
and this,
did.
and this.
That's
and then
right.
If you remember that, you can be like, wait, 20 can go into itself.
So then 20 is,
found it without
yeah,
times.
I could have found it without writing those out. You're right, because I knew 20 went into all of them, so I could have said that's what it was. I wasn't even thinking, I was just doing the work, not even thinking about it. Okay, that's the end of the lesson, and we are going to do a few of the practice sets.